Okay, cool. Hi again. So the other side of JAX is that we do have 60+ faculty working on a diverse range of topics. There are dedicated consortia to aging, rare diseases, and like dementia. And I think addiction is also one of the bigger consortia at JAX. So I work in research IT. Rid of this. There we go. This is my team in research IT. So essentially we are a subgroup of IT that is responsible just for supporting those 60+ faculty researchers. We don't touch any of the rest of JAX's mouse model business. So our job is supporting research. Our team's job is supporting image applications and machine learning. Just this past year, we added that little machine learning tag on the top. So we do provide image data management. We run 2 OMERO instances. We provide users with support and training on image analysis workflows, and we do some development of various libraries. Eric mostly around our OMERO instances, and Peter and Fernando do a lot of development around machine learning and more analysis workflows. Okay, so I did mention we run 2 OMERO instances. The first one would have fit better in the other session, so I won't focus too much on it, but know that we do run an OMERO that is internal to JAX. It's run on-prem. This is for active research. This is where researchers put their data. Typically, my faculty core puts their data into our automated research system and put that funnels into our OMERO. Eric can tell you more about that automated research import system if you're curious. But we also run a fully separate instance of OMERO that runs on GCP in the cloud. This hosts public data from JAX. If you go to images.jax.org right now, you will see all of our public data that we have put on there. How that works is we run that on Google Cloud using Kubernetes. I can talk forever about this, and that's not the point of this presentation, so please come find me later if you're interested in the details. About 2 years ago, we moved all of our image files, including the kind of original proprietary files, onto object storage, which OMERO mounts as a file system using GCS Fuse. There is a little bit of a slowdown with that, but it's worth it for the cost saving for us. Researchers put in a ticket, because we're IT, to request that we move a whole OMERO data set, or a copy technically, from the internal on-prem OMERO to this public OMERO. So it keeps all of their OME data model annotations, whatnot, with the images. We use OMERO CLI transfer for that, which is another library that Eric developed, packs up the whole thing, copies it to another OMERO instance. About the same timeline, about 2 years ago, we started requiring a very simple set of minimal metadata for people to submit to put their data on our public OMERO. This includes license, contact, and description. And a little something special for us, Research IT, my department, fully subsidizes our 2 OMERO instances, including all of the storage for that. That might change in the future. Things are happening this year. However, so far, researchers don't pay for any of this. That comes out of our department. So what are our goals with the public data repository? Probably similar to your goals. We want to store images for an extended period of time. We like to pretend it's indefinite, but we all know that's a big task. And primarily, we also want to convince other people, like funding agencies, that we can store images for an extended period of time. So there are definitely cost and disaster recovery considerations with that. We do want to provide metadata search to make images findable. So we do need some amount of minimal metadata. I know people here like talking about that topic. We need to enable image viewing because no one likes just a list of files on the internet. And so it's particularly in bioimage land, that's quite difficult because there are so many different types of file formats and they're very big. So there are compute and network limitations with that. And a big question mark with image data repositories or public ones is, do we make the image data files available to download and how? Currently, our model is just please contact us if you'd like the image data. I'm seeing a lot of nods. But there are definitely some security and cost considerations for if you want to make that slightly more automated or more public. So the pain points for us in those right now is that the search functionality on OMERO Web is quite not intuitive on a public instance for people who don't understand how it and the regex part of it works. And as I think Josh or Jason was saying last night, OMERO Web UI hasn't changed in a decade. So it's maybe not the prettiest thing for public users to jump into. So one of our long-term goals is to have a prettier front end. IDR has already done amazing work on this. That's the goal. We have found that OMERO Viewer, especially over GCS views, is slow because bioformats is having to run on the fly and mounting object storage as file system. There's just some slowdown there. So people who have viewers reading a more universal format directly from the image data bucket. And I saw a lot of nods. I talked to people about this last night. A lot of us don't have a working solution for file downloads from public OMEROs. And that is a pain point for us increasingly as we get more external collaborators, people using this as maybe a file sharing platform. So ideally, our solution that we're hoping for in the future is that OMERO provides a signed download link directly to our bucket. That's kind of a goal for us this year. We'll see if we get to it. So all of those things kind of took things that OMERO does and moved them out of OMERO. So we've got the download and the search and the viewing are now things that OMERO is not responsible for, but we're moving into separate applications. And one big key to this, I mentioned a universal format, or this slide mentions a next generation file format. So I can't go very farther until I give a very small introduction to OMERO. You'll hear so much about this weekend that I'm going to try to not get into the specifics. This is the weekend, this week. So I'm just going to say the brief bits that are important to us. It is considered a next generation file format. You'll sometimes see it OME NGFF. That is optimized for storing bioimaging data on the cloud and especially getting viewed by remote viewers. It uses ZAR to chunk multidimensional arrays and adds the OME metadata on top of that. And something important to us is that we just moved from OME ZAR 0.5 or 0.4 to OME 0.5 late last year, so a few months ago. And that moved to ZAR v3, which implements sharding. The important thing here is that significantly decreased the number of files needed to represent a ZAR. That's really the main point of this slide. So last year at OME 2024, we announced and made a big splash saying that all of our imaging data on images.jax.org, all of our public data was available in ZAR v2 in the NGFF older spec that was recent last year. Caveat, except the high content screening, which made some people very sad. Side note, that's the only photo we had from OME 2024. So we all need to be better at proving that we're an active community. Please take pictures. And so all we did with that really is we converted our data to OME ZARs and we linked it as a key value pair on OMERO. We didn't do anything fancy in OMERO. We're not using the ZARs as a backend for OMERO. OMERO still has the original files as the imported data. We've just linked the ZARs, and then that link can be loaded into various browser viewers like Vizar or PPath or Napari. So we're moving slightly outside of OMERO for that, but we haven't done anything fancy with the OMERO imports. The whole community then band together for the OME 2024 NGFF challenge. So us and a bunch of other awesome groups submitted some data or did the work to push to this next OME ZAR spec, this 0.5. So that was building the spec itself, building the tooling, and demonstrating. If you go to this GitHub link, you'll find this awesome distributed or federated data repository where all of us institutes are hosting our own data in this new czar spec, but this data repository can query that information remotely and shows a nice search functionality. So the point of this challenge was to prove that this is possible and push this new spec forward. So caveat, we discovered this. czars are massive in two ways. So we typically have NDPI files. We have a lot of whole slide imaging at JAX. Our total data bucket recently was about 30 terabytes and about 500,000 objects. And when we converted that to czars, we had more than a 10-fold increase in size. And particularly for us, that's because the NDPIs are compressed and then they get uncompressed into the czar format. And so that causes a size blow up that you might not see with other files, those of you who are not whole slide imaging people. But what everyone is seeing is this massive increase in number of objects. Multiple 100 million objects is quite difficult to work with, actually. So converting to czar v3, thank you to Eric Perlman. If you want details on how he made the GCP conversion pipeline for this, please talk to him. But we went from over 100 million objects to 2 million objects. That's over 98% reduction in number of objects last month when he converted these to czar v3 or the OME czar spec 0.5. And we actually also saw a decrease in the size as well, about a 30% decrease in the size. So pushing the spec going forward, this is awesome for us. We're moving in the right direction. I'm hoping that just like last year, where we pushed this spec to a new place, we can find a way to push it again this year. So where are we personally going from here? We want those signed download links that I mentioned. Ideally, we might start linking to in-browser czar viewers instead of relying on the user to copy and paste the URL, starting to make a nicer front-end experience where users can just click to another viewer instead. Currently, only the NGFF challenge has RO crate metadata. That was part of the challenge that didn't get into the newest spec. So we need to revisit that metadata. We need to collect more of our minimal metadata and maybe move that into the spec. And then personally, that amount of data is costing us a lot. And I said that we're subsidizing that entire cost for our users. So we need to figure out how to save costs. I'm currently working on moving things colder. I'm sure some of you care about that, but I wasn't gonna make the whole room sit and be discussing colder object storage. So then one last reminder, data repositories are a massive amount of constant work. So there's a whole lot of behind the scenes happening, operational work just to keep OMERO and everything afloat. Data ingress takes a lot of human time. There's the question of, do you convert to OMEs or in batches? If on top of those, we can work on development improvements, we're really wanting some automation, infrastructure improvement, and then maybe some extra features on top. And then there's a lot of communication work that happens. A lot of the people in the earlier session were talking about how to get motivation and funding for this. We need to talk to both users, institutional leadership, funding agencies, and we need to get the microscopy vendors on board to get OMERO off the ground with them. So kudos to everyone who does that work. Thank you. And thank you to my team, Eric Perlman, who did all the conversions, the rest of JAX RIT that supports us, and all of the communities who are here today.
Thank you very much, Kiya. Questions? I think we had Beth first.
Yes. So you said people downloading stuff from public. How are you guys thinking about managing egress costs? Does it solve like a request or pay model, or?
That's an awesome question.
Full stop.
Yeah. We haven't really figured it out right now, technically, because of we have the data management pre-production, like Katarina was talking, it's all the same. So actually, right now, we do a lot of, here's the on-prem data you can have. It's the exact same as what's on public. But for download costs for the cloud data, yeah, great point. Yeah.
Like the 10x of memory consumption sounds crazy and like a really bad thing. And I was wondering, what is the reason for this? Is NDPI lossy compressed, and do we not have lossy encodings?
Yeah, well, so NDPIs are lossy compressed, get uncompressed to ZAR. You don't really want to lossy compress on top of that. Go back and forth a bunch. So ideally, I believe we would take the lossy compressed tiles directly into ZAR.
So that would be an additional codec to take stuff as is and be able to decompress.
Yeah, and I just don't think we're there yet.
And it does limit your chunking and sharding a lot, right? Because you need to obey whatever NDPIs were doing for the compression.
Do they do just JPEG? Because this is what I saw on the internet. So we're limited by 8 pixel grid. That's fine. Thanks.
Yeah, so if we want to make that happen, that would be great for us in particular. I saw it, yeah.
Yeah, so about the sharing technique, there, for me, a viable solution could be about implementing a BitTorrent protocol, because that's how we have been sharing movies and photos from the last 20 years. And also, I'm not aware how if it's possible to have like a personal storage, and we can access via torrent to the other files, and we can share the data sets without incurring into cloud expenses. Have you ever considered using the BitTorrent sharing?
We have not, partially because our first issue is actually permissions, like how to get public access or user permissions to the data, not so much the how do we get it out of the thing. So we're a little bit earlier than that process, but if you want to talk that next step, find me later.
Yeah, thank you.
Yeah, so when you have, when you're moving with CLI transfer from the internal, like pre-pub to the post-production, you said that there is just a minimal set of metadata, but what if there is more metadata on the pre-pub side? Is that that is maintained?
Yeah. So our automated import system, users put a spreadsheet values get into key value pairs. When that moves public, key value pairs get packed up with all of the other OME data model stuff and get moved into the public OMERO, just as it looked on the private. I think the only things that don't get moved are rendering settings, because you implemented figures a little bit ago. So I think it's just rendering settings that are not moved to public.
It's working.
Cool.
Thank you, Kiya, again.
And